Hello everyone. So today we're going to go over section 6.1, angles and angle measures. So a quick review. Angles can be measured in degrees, where 360 degrees is a full rotation. So we have rotational angles that are formed with an initial arm, in this case in red, and then we rotate this initial arm about a vertex. So our vertex this time is going to be on the left here. And then we have a terminal arm after the rotation. So this is our terminal arm in our example. And the angle in between is the rotation angle. So this is the angle in question, and we'll label it with theta. Okay, so on a coordinate plane, the initial arm is the positive x-axis, and the rotation, the positive direction will be counterclockwise, and the negative direction will be clockwise. So let's get some angles in standard position, starting with number 1 here. So again, for the first couple of examples, we're going to add in the initial arm. Okay. Also, when it comes to the coordinate plane, we have quadrant 1 on the top right, quadrant 2 on the top left, the bottom left is quadrant 3, and the bottom right is quadrant 4. Okay. And we know that since the positive x-axis is the initial arm, the angle will be 0 degrees here. The right angle is 90 degrees. And then 180 degrees is the negative side of the x-axis. And finally 270 degrees pointing straight down. So in this case, the terminal arm will be 110 degrees from 0. So it should be somewhere in quadrant 2, and this would be a reasonable sketch. Let's go ahead and add in here 110 degrees. So likewise, we can also work in the negative direction. So again, this is 0 degrees. Oh, also here, positively, this could also be 360 degrees if we complete one full rotation. So anyway, so back into example B, if we are to draw negative 150 degrees, then we start at 0, going clockwise in the negative direction, we have negative 90 degrees, negative 180 degrees, and then negative 270 degrees. So in this case, the terminal arm will be in quadrant 3, somewhere around here. And since the angle is negative, we'll draw the angle clockwise, like so. And this is negative 150 degrees. So notice that the same angle, the same terminal arm can be of two different values. For example, this could be 90 degrees or negative 270 degrees. And those are called coterminal angles, which we'll explore in greater detail in just a bit. Okay, so for now, let's move on to the next couple of examples here. We have 400 degrees, so consider that 400 degrees is equal to 360 degrees plus 40 degrees, which means we actually complete a full rotation and then have 40 degrees more to go. And therefore our terminal arm will be somewhere around here. But we must have went around the circle once and then reach 400 this way. Okay, so similarly, negative 500 degrees is equal to negative 360 plus negative 140 degrees. Okay, so we will be in quadrant 3. Okay, so somewhere around here. And this time we go clockwise around once, and then another 140 degrees to go after that. So this will be negative 500 degrees in example D. So another way to draw angles in standard position is to use coordinates of a point that is on the terminal arm, like we have in example 2 here. So the point A has coordinates negative 3, positive 4. So it's going to be in quadrant 2, and if we are to add values here, negative 1, negative 2, negative 3, and then 1, 2, 3, and 4, this point should be in somewhere around here. And we can add in our terminal arm. Okay. So the rotational angle should look like this. Now we don't know the degree measure, but we do know where the terminal arm is going to be. Similarly, in the next example, point A has coordinates negative 7 and negative 2. So that will be in quadrant 3. And since the x value is going to be, is greater than the y value negatively, we expect the terminal arm to be closer to the x-axis. So something like this. And this would be a reasonable sketch. And this is our angle starting with, starting at the positive side of the x-axis and ending at the terminal arm that goes through A. Okay. So now let's look at coterminal angles in greater detail. Angles in standard position that have the same terminal arm are coterminal angles. So for example, 150 degrees is somewhere here. It is in quadrant 2 since it is somewhere between 90 degrees and 180 degrees. Now, it is 30 degrees away from 180. And so that's how we can get 150 degrees. Okay. In example B, negative 210 degrees. So again, we start with 0 degrees here in the positive x-axis, and then we have negative 90 degrees, negative 180 degrees. Sorry about that. And then negative 270 degrees. So we know that since the angle is somewhere between negative 180 degrees and negative 270 degrees, once again the angle will be in quadrant 2. When we draw the terminal arm, or sketch the terminal arm, notice that we will go past negative 180 degrees and go 30 degrees more in the negative direction. So that is to say that these two angles actually have the same terminal arm. So 150 degrees and negative 210 degrees are coterminal angles. Okay. Next up, we have 590 degrees, which is equal to 360 degrees plus 230 degrees. So this will be in quadrant number 3. Since we'll go one full rotation around, and then 180 degrees more, and then another 50 degrees on top of that. Since 230 degrees is equal to 180 plus 50. Okay. So now let's consider negative 230 degrees. We know that this is going to be in quadrant 2. Since it is past negative 180 degrees, but not negative 270. So it's going to be somewhere around here. So this would be 50 degrees. And so parts C and D are not coterminal angles. However, if we were to graph instead 230 degrees positive, then that would be coterminal with 590 degrees. Okay. So the idea of coterminal angles is that we can start with any angle and add or subtract integer multiples of 360 degrees and have a coterminal angle. To simplify our work, it is often a good idea to have what's called a principal angle, which is the smallest positive rotational angle that has the same terminal arm. So for example, the principal angle of 590 degrees is 230 degrees. Likewise, for the principal angle of 230 degrees is also 230 degrees. The one thing to keep in mind is that principal angles are between 0 and 360 degrees. So the smallest positive of the coterminal angles. Okay, so next we have what's called a reference angle. So a reference angle is an acute angle that's formed between the terminal arm and the x-axis. Okay, this could be the positive or negative x-axis, and we have looked at some reference angles already. Just going to go ahead and draw these 4 angles here. 150 degrees will be 30 degrees less than 180, so it will be in quadrant number 2. Okay, 285 degrees will be 15 degrees more than 270, so it will be in quadrant 4. 22 degrees, of course, is just in quadrant 1, so somewhere around here. And then negative 269 degrees is 1 short of negative 270, so it will be in quadrant 2. Okay, so those are our terminal arms. So just going to go ahead and draw in the angle 150 degrees for the first one. Okay, 285 for the second. 22 degrees for the third. And finally, negative 269 in the fourth example here. Okay, so the reference angle in each case is the acute angle formed with the terminal arm and the x-axis. So in the first case, it is simply 30 degrees. In the second case, that's the reference angle. and it's going to be 75 degrees. To indicate the reference angles, sometimes we can use theta with a subscript r. So here we go, theta r is equal to 75 degrees. We know it is 75 degrees since the line pointing straight down is 270, 285 is 15 degrees more. So, but quadrant 4 has to form a right angle, so if we take 90 and minus 15, we get 75. Okay, 22 degrees. The reference angle is just going to be 22 degrees as well. And finally, the last one, the reference angle here. Notice that it is 1 degree short of negative 270, so the reference angle in this case is going to be 89 degrees. Okay. So an important part of this unit is using radian measure of angles instead of degree measures. So we'll look at what a radian measure is. So the measure of an angle in radians is the length of the arc forming the angle divided by the length of the radius. In short, arc length divided by radius. So what does that mean? Consider what happens if we go all the way around the circle. So 360 degrees like we have here. And then this will be the arc. So the arc length in this case will be just the circumference of the circle. So that will be 2 pi r. And the radius, of course, is just r. So effectively, we have 2 pi r over r, which is 2 pi. And that is an angle measure in radians. And that is to say, 360 degrees is equal to 2 pi radians. Okay. Notice that this is true no matter what the radius was, since the r values were eliminated when we simplified the expression. Okay, so this expression here can be further simplified to just 180 degrees is equal to pi radians if we divide both sides by 2. And that allows us to change angle measures in radians to degrees, and then from degrees to radians. Okay, so radian to degree that's when we multiply the angle measure by 180 degrees over pi. Okay, and then from degree to radians, we multiply by pi over 180 degrees. Note that this symbol right here indicates that the angle measure is in degrees. If that symbol is not written, then the angle measure is assumed to be in radians. Okay. So let's look at how we can apply what we just saw to convert from degrees to radians, starting with 120 degrees. Simply multiply by pi divided by 180 degrees. In this case, we have a common factor of 60, so this reduces to 2 and 3 respectively. So 120 degrees can be simplified to 2 pi over 3. Likewise, for the second example, here we have negative 315 degrees. Again, we're going to multiply by pi and divide by 180 degrees. In this case, we have a common factor of 45. So this would be -7 and 4. So negative 315 degrees reduces to, in radians is -7 pi over 4. Okay. Next one we have 205 degrees. Again, multiplied by pi divided by 180 degrees. In this case, there's a common factor of 5, so this reduces to 41 and 36. So in radians, 205 degrees would be 41 pi over 36. Okay. So of course, we can also convert from radians to degrees simply by multiplying by 180 and dividing by pi. So of course the pi's would be eliminated in this case, and we simply have 180 degrees divided by 4, which is 45 degrees. Okay, next one, same idea here. Again, the pi's are eliminated. 180 divided by 3 is 60, and 60 times 7 gives us the angle measure of -420 degrees. Okay. Last case. Notice here this is not written in terms of pi, but the same rule applies. So multiply by 180 degrees divided by pi. Need to use a calculator in this case, and we'll get 89.95 degrees, which is very close to 90 degrees since 1.57 is very close to pi over 2. Okay. So last part of this lesson will be on arc length. So recall that the measure of an angle in radians is arc length divided by the radius, in otherwise known as theta is equal to A over R. So if we rearrange this, we get A is equal to R times theta. Okay. So let's look at some examples. It says here, calculate the arc length of a sector of a circle with diameter 9.2 meters if the sector angle is 150 degrees. So let's go ahead and draw that. Here's the center of the circle. So this would be the sector, something like this. We know that this is 150 degrees, and we're looking for the arc length that goes between the x's, and we know that the radius of the circle is 4.6 meters. So using A is equal to R times theta, we can have 4.6, the radius, multiplied by 150 degrees times pi over 180 degrees. Now this part is necessary because the A equals R theta formula works when the angle is in radians, not in degrees. And once we multiply everything out, the arc length is approximately 12 meters. Okay. Next question, pendulum 30 centimeter long string. So this is 30 centimeters long. Swings through arc of 45 centimeters. So this is the arc length. and we are to find the angle in between. Okay, in both degrees and in radians. So in this case, we once again have A is equal to R times theta. So the arc length is 45, the radius is 30, and then we have theta. So theta is equal to 1.5 radians, which we can also convert back to degrees, multiplying by 180 degrees and dividing by pi, which gives us approximately 85.9 degrees. Okay. And that's it. So that is it for section 6.1. Thank you for listening.